Okay, welcome to the last video in Unit 6. In this video, we're going to tie everything together, the writing, the formulas, and then balancing the equations. So, a few things you need to know about writing the chemical equations. The reactants are written on the left side of the equation. Products are written on the right side. And then you have to draw an arrow pointing to the right, which means produce or yields. Here's a few steps you need to know for writing these equations. So go ahead and pause this and write these down. Alright, so let's do this first practice problem together. It says a solid piece of zinc reacts with hydrochloric acid, which is HCl, to produce a solution of zinc chloride and hydrogen gas as the products. When you're writing these equations, you need to remember the term Brinkelhoff. We talked about Brinkelhoff in the last video, and these are all of your diatomic elements. So whenever you have an element that's not bonded, you need to double check and see if it's diatomic and put a 2 next to it if it is. So let's go ahead and start this. It says a piece of zinc. So zinc, we have Zn. It's an element by itself. So check and see if it's part of Brinkelhoff. Since it's not, it can be all by itself. Then it says it reacts, so I'm going to put a plus sign with hydrochloric acid. Hydrochloric acid, it tells you, is HCl. Then it says to produce. Produce means we're going to put this arrow here. And it says it produces a solution of zinc chloride. Well, zinc is Zn. It's a transition metal, but it's one of those transition metals that always has the same charge. It always has a +2 charge. Chloride is chlorine in a bond. Chlorine is group 17, so it has a -1 charge. Take those numbers, not the positive and negative, and crisscross them, and you get ZnCl2. And then it says it also produces hydrogen gas. So we have plus H. Now H is all by itself, so we need to see if it's diatomic. This H in Brinkelhoff stands for hydrogen, so I'm going to put a 2 here. Next thing you need to do is make sure it's balanced. So if I have zinc on this left side, there's one of those, and there's one on the right, so that's good. You can leave it alone. H on the left, there's 1, and on the right, there's 2. So what I need to do is change this coefficient to a 2. That changes H to have 2, but it also changes Cl to have 2. So since I have 2 Cl's on the left, and I have 2 on the right, you can leave that alone. So your coefficients come out to be 1 here. Now remember, you can put that 1 there, but you will not see that on your test or your quizzes. It'll just be left blank like this. Zinc plus hydrochloric acid makes zinc chloride and hydrogen gas. There's your final balanced equation. Okay, so let's move on to number 2. We have sulfuric acid is reacted with a solution of sodium hydroxide to produce a solution of sodium sulfate and water. So I'm going to pull this polyatomic ion chart up since we're going to need it to write some of these formulas. So first we have sulfuric acid, H2SO4. It gives us the formula, so just go ahead and write it down. H2SO4 says it's reacted, so there's your plus, with a solution of sodium hydroxide. So sodium is Na. It's group 1, so it has a +1 charge. Hydroxide is right over here, and it's an OH. I'm going to put it in parentheses until I know how many there are, with a -1 charge. Take those numbers, place them on the opposite element. So this becomes NaOH. There's just one of those, so I dropped that parentheses. It says to produce a solution of sodium sulfate. So sodium sulfate, I have Na. It comes from group 1, so it's a +1 charge. Sulfate is a polyatomic ion right down here. I'm going to put it in parentheses, SO4 with a -2 charge. So I take this 1 and place it outside the parentheses. Take this 2, place it over by sodium, becomes Na2. And since I only have one SO4, I'm going to drop that parentheses. And then it says water is another product. So plus H2O. Okay, so now we need to move on to balancing this one. I'm going to start with the polyatomic ions and the metals before I do hydrogen and oxygen. It makes it a little bit easier. So here, SO4 is a polyatomic ion, we need to balance it as its own unit, as its own element. So I have one of those over here, and I have one SO4 over here. So I'm going to leave that alone for now. On this left side, I have one Na, and over here I have 2. So I'm going to put a 2 in front of this to make 2 NAs. Now I'll move on and balance my oxygens. So since I have 2 O's right here, I need to put a 2 in front of this H2O because I only have 1 on the right side. Now that my oxygens are balanced, I need to double check with the hydrogens, okay? So if I have 2 times 2 hydrogens on the right side, I have 4 on the right, so 4 H's over here. And then on this left side, I have 2 H's right here. And then right here, I have 2 more. So that adds up to being 4 H's on the left side. So those are balanced. So your final balanced equation comes out to be 1 H2SO4 plus 2 NaOH's produces 1 Na2SO4 plus 2 H2O's. And there's your final answer for that question. All right, let's move on to number 3. So we have chlorine gas is bubbled through a solution of lithium iodide, and the products are found to be a solution of lithium chloride and solid iodine. Now, first thing, I already noticed that there's elements by themselves, chlorine and iodine. So I want to go ahead and write down Brinkelhoff so I can double check if I have any diatomic elements. So first, let's start writing this. We have chlorine gas, so Cl. I look up here, it's part of Brinkelhoff, so I need to put a 2 here. It says it's bubbled through a solution of lithium iodide. So I have lithium. Lithium comes from group 1, so it has a +1 charge. Iodine is iodine in group 17, so it has a -1 charge. Crisscross those, and I get Li. And then it says the products, so arrow, are found to be a solution of lithium chloride. So lithium, again, is group 1. Chlorine is in group 17, so I have a -1 charge. Crisscross those, and I get LiCl. And then it says the other product is solid iodine, so plus iodine. I need to double check with Brinkelhoff since it is alone. I stands for iodine, so I need to put a 2 here. So go ahead and now start balancing. If I have 2 chlorines on the left side, I need to put a 2 here and make 2 chlorines on the right side. Now I have 1 lithium on this left side, but I have 2 because of this coefficient on the right side. So I need to put a 2 right here. Now you need to check with iodine. If I have 2 I's here and I have 2 I's here, this equation is completely balanced. So your final chemical reaction here is Cl2 plus 2 Li makes 2 LiCls plus 1 I2. And there is your final balanced equation. All right? Lastly, we have solutions of silver nitrate and barium chloride are mixed, and the products are a precipitate of silver chloride and a solution of barium nitrate. So what we need to do is start writing these formulas. I have silver nitrate. Silver is Ag. It's a transition metal, but again, it's one of those that always has the same charge. Ag always has a +1 charge. Nitrate, if we look over here, is one of our polyatomic ions. It's NO3 with a -1 charge. I'm going to take this one, place it outside of the parentheses, put this one in front of Ag, and so my formula for Ag NO3 looks like that. It says it's reacted with barium chloride. So barium chloride is Ba. Barium comes from group 2, so it's a +2 charge. Chloride is chlorine from group 17 with a -1 charge. Take those numbers and crisscross them. You get BaCl2. Then it says the products, so I draw an arrow, are silver chloride. Silver is Ag. Remember, it's a transition metal that always has the same charge, +1. Chloride is chlorine We just looked that up. It has a -1 charge. Crisscross, and we get AgCl. Then the other product is a solution of barium nitrate. So barium comes from group 2, so it's a +2 charge. Nitrate is one of your polyatomic ions, NO3, with a -1 charge. And you take this 1 and place it in front of barium, and you take that 2 and place it outside the parentheses of NO3. So this becomes BaNO3 2. Okay? So let's start with our metals here. We have 1 Ag on this left side, and I have 1 Ag on the right side. Next, if I look up NO3, this is a polyatomic ion, so I need to balance it like it's a unit. I have 1 NO3 right here, but if I look over here, I have 2 NO3s. So what I need to do is put a 2 in front of this AgNO3, and that balances the nitrates. But remember, we just said I had 1 Ag on this left side. Now I have 2. So I need to put a 2 in front of this Ag to make those equal. Next, I look at barium. I have 1 barium here and 1 here. So those are good. And I have 2 chlorines here. And because of this coefficient, I have 2 chlorines over here. So the final reaction looks like this. 2AgNO3 plus BaCl2 produces 2 AgCls plus 1 BaNO3 2. So there's your final balanced equation. Now you've reached the end of the Unit 6 videos. Thanks for watching.